Okay, so for this is my fourth video here, and we're going to run that last model specification. So this first one, we ran party identification. We were able to explain about 0.79, so about 79% of our variance, just with the dichotomous variable. That's really high. We had some residuals heteroscedasticity in here. This wasn't really completely uniform through there. And when we went to the residual test of normality, yeah, we rejected the null that it was not normal. We rejected the null that it was normal, so we've got an issue there with normality. When we went to the second model, we were able to explain about 84% of the variance in the dependent variable, and so that's a little bit better, but we should anticipate some improvement just because we went to a continuous variable. So it still tells me that party was really strong here, so this is kind of a delicate issue. But maybe with this last model we'll see some separation on the basis of ideology. This one, notice the residual, the histograms are a lot better because we have a continuous variable, and the continuous variable it helps to distribute the variance found in that dependent variable and creates much more uniform patterns within the residuals. And so the last thing that we need to do here is we need to run our model with both dimension scores. So let's just do analyze, regression, linear. I had vote score and I had my first nominate score. I'm going to add in my second nominate score. And so mine were, again, liberal. Liberals tend to support campaign finance reform more than conservatives did. And so I ended up inverting both my first and second dimension scores. I did both of those here, and I'll put both of them in here. In terms of the plot, so I'm going to keep my z residual, my dependent variable. We'll use those plots in the write-up of the assumptions. And the last thing I'm going to do is I'm going to save the standardized residual. So I'll get a third column with the standardized residual value in it out in my database. Okay. Click OK, and we'll run this. Now this one, I didn't get a big increase. I got about 8.85, so let's see what we had there. 0.85, and the other one was 0.84, so I got about a 1% increase. But again, as you get into like 85%, a 1% increase is bigger. You know, it's not much left that you can actually do. So I've got my two independent variables there. I've got an R-square of 85%. I've got a standardized 432 is my degrees of freedom. And so I'm going to have, it's actually, should show you a little bit different than that. Your degrees of freedom in this one, you've controlled for two regression parameters, and so it should be 431. I'm not sure why it totals like that. It's a little bit confusing. But notice down here I've got my two parameters. I've got a very big parameter, a small standard error for my first dimension score, and I get about a 50 t-score. Remember, you only need 2 to get it significant, and this one is very significant. But notice I've got a second dimension score here as well of 11.75%. A standard error that's 2 versus that, and that gives me a t-score of 5, so that's a very strongly significant result as well. And when we go to the histogram, notice this is even improved. It's got a little bit of skewness to it though, right? So notice over here we've got a little bit of skewness here and a little bit of skewness there. So we may not have a completely normal distribution, but it'll be closer. And notice here, we still have kind of the clumping because we only have so many votes in our sample, but it's a little bit better. It's not completely random, but a little bit better. Okay, good. Let's do our analyze, correlate. And so I'll analyze, correlate, bivariate. And here, let's just get rid of both of these because I want to make sure that you know exactly what we're doing. I want to do DW nominate 1 and DW nominate 2, and I need to do the third standardized residual value, ZR3 here. See, notice that over there is labeled ZR3. That just tells me it's the third one I saved. And remember, if you run multiple models, you need to delete your residual after you do it. Make sure that you use the right residual value. We're going to run those real quick, and we should get a correlation table. The best way to do is go down here to the standard residual. This row, it should be 0 for DW nominate 1, and it should be 0 for DW nominate 2. So that tells me that the model successfully captured all the variance associated with the first and second dimension scores, and the residual is no longer correlated at all with those variables, and that means the model worked. Let's also do the last bit here. Let's go to Descriptive Statistics Explore, and let's get rid of that standardized residual. Let's go to the third ZRE3, and I'm going to do plots. I don't care about any of that, but I want my normality plots with tests. Click OK. And I'm going to run down here, and 0.956, it's still significant. Let's look and see how close it was. So I have 0.956 here as the statistic. If I go up here, .929, so at least we're going in the right direction. And let's check this one. And that one is, let's check the next one. Okay, there it is. And then down here we should have 0.772. So obviously it gets better with every inclusion. And because both of these models are, both of these parameters are significant and strongly significant, I would be willing to say, as far as the general conclusion for my model, that the ideological explanation, the trustee perspective, is more influential at explaining support for campaign finance reform than the partisan explanation. So this may be something that is more consistent with the trustee view. It's an issue that is very closely related to members of Congress and their electoral goals. And so they may be willing to vote in their particular interest whenever it may not be directly correlated with the party stance on something, or it may not be related to the district stance on what it is. And so, again, this kind of tells you that members of the parties may break with their party stance and vote their ideological perspective anyway. Now, it would be better if we had a little bit more separation between the R-square values. But again, once we get to 75 or 79%, it only means you've got 20% left that you can actually explain. And so a 1 or 2, 3% increase from 79% is pretty big. And so here what we show is that the ideological explanation is reasonably good and probably better than just simple party. Of course, my bill's labeled the bipartisan campaign finance reform, so that would tell you a little bit that there's some bipartisanship here. It's not directly party line stuff, and so this is one where we might anticipate having some of that more moderate behavior. Notice this last plot here, the Q plot, is pretty good. That's dips on one side, but it stays pretty close, right? And you get some lines there, and we don't have this second line. We got kind of a dip and a sinai, but it's not that double curve that we had the other one. Right? So deviation from normal, and it almost takes a normal curve on the back side of it, right? So it's almost an inverted normal curve, and that's good because that'll tell you things are about right. Okay, good. So all in all, it looks like for my particular bill, we've got a pretty good ideological explanation that should be more consistent with trustee behavior. I can reject the null hypothesis for party, and I can reject the null hypothesis for ideology. But of the two, the ideological model is a little bit better, and it's substantively better in a way that tells me that it's the better explanation for my particular bill or type of bill.